All right, number 4, we have a function h of x, and we're going to write the vertex form, which we're going to complete the square. We're going to identify the vertex, the x and y intercept. We're going to sketch the function, determine the axis of symmetry, determine the minimum or maximum value, and then write the domain. So again, the nice thing about this problem is a lot of this information is given just from the vertex form. So once we get it to vertex form, we will have the minimum or maximum value. We will have the axis of symmetry and the vertex. So once we do this one part, that'll complete 3 other parts. So let's just kind of jump right into it. So I'm going to go through the completing the square part a little bit more quickly this time. So we have 2x squared minus 7x. All right, so we don't have the constant, so we don't have to move anything. But when we complete the square, have to have the leading coefficient as a 1, so we're going to factor out the 2 first, leaving us with x squared minus 7 over 2x. Now I'm going to put plus a blank spot. I'm going to set this equal to 0. To complete the square, we take this middle term, divide by 2 and squared, so negative 7 over 2, divide by 2. So what happens, normally I'm dividing by 2, it goes to the bottom. So if you divide by 2 again, it just multiplies the denominator. Divide by 2, that will give me negative 7 over 4, and then you're going to square this term. I'm going to place that here, negative 7 over 4 squared. Now, actually what's happening, whatever you add to one side, because this is a new term, I have to add that same thing to the other side. However, when I square this, negative 7 squared will give me 49, and 4 squared will give me 16. I don't want to write 49 over 16 because inside the parentheses, this 2 is going to get distributed to every single term. So that means, in effect, this term is going to get multiplied by 2. So the 49 divided by 16 is going to get multiplied by 2. And instead of multiplying and making it bigger because we want to reduce to lowest terms, I'm going to take 16 and 2 and divide both terms by 2. And that will give me 49 divided by 8 that I need to add to this side. Okay. And so that will complete the square for me. I'm going to factor it, so I have the two squared terms, x and a minus 7 over 4 squared equal, I should say, 49 divided by 8. And if I subtract the 49 divided by 8, this will give me 2x minus 4 squared minus 49 divided by 8. Okay, so with this having been done, we can say that our vertex is 7 over 4 negative 49 over 8. We know that since this leading term is positive, this parabola opens up, which is going to give us a minimum. That minimum should be the y-coordinate of negative 49 over 8. The axis of symmetry is x equals whatever the x-coordinate of the vertex is, so that's going to be x equals 7 divided by 4. And from here we can also talk about the domain and range. Domain is going to be all real. It's going to be the case unless we have a restriction, from negative infinity to positive infinity. Your range starts from a minimum and goes up, this minimum value. So our range will be negative 49 divided by 8 up to infinity. It's going to be in parentheses. I think that gets pretty much most of it. We can sketch it and what else else are we looking for? Sketch. I think that might be, oh, X and Y intercept. X and Y intercept will be better to do from here. So if we do Y intercept, we plug a 0 for X, that means this zeroes out, this zeroes out, because 0 squared is 0, 7 times 0 is 0. So we end up getting 0, 0 for our Y intercept. Because X and Y are both 0, this is also probably going to double as a X intercept, but let's find that. So let's say 0 equals 2x squared minus 7x, and this is for the X intercept. This time the Y is 0. We will factor out an X. That will give us 2x minus 7x. Set both of these equal to 0, so we get x equals 0. So when x is 0 and y is 0, we get that ordered pair 0, 0. And then 2x minus, it shouldn't be a 7x, it should just be 7. 2x minus 7 equals 0. Add 7. And divide by 2. So x is 7 over 2. The other ordered pair is 7 over 2, comma 0. So this should be all of the parts that we need. Now let's just plug them in. So write the function in vertex. So no, it says write the function in vertex form, and then it says the vertex of the function. So this just wants the vertex. I tried to put the actual vertex form in. The vertex is 7 divided by 4 and negative 49 divided by 8. It says be careful of commas. The vertex form of h of x. Okay, so it says the vertex form. Okay, they want the vertex form, not the vertex. Be careful here. So 2x minus 7 divided by 4. Quantity squared minus 49 divided by 8. Okay, so check. Identify the vertex. Okay, so this is where we write the vertex. 7 divided by 4 and 49, negative 49 divided by 8. It's already got the parentheses there for me. Can't see it very great, but we're getting green checks. Okay. The next part, determine the x-intercepts. Okay, so we already have those lined out. 0, 0, and be faster if I do this. 7 divided by 2, 0. All right. The y-intercept is 0, 0. We're going to sketch it. So in order to sketch it, we're going to just plot a few points. So we're going to use this since we're not on whole number points. With the fractional points, you want to get exact, so we have to use this. I'm going to plot a point. So it says enter x and y coordinate. So we're going to do let me see, I want to go from left to right. So 0, 0. Yep. Okay, so we're going to put 0, 0, one of the points. I'm going to say add another. we're going to do the vertex, 7 divided by 4, and negative 49 divided by 8. And we're going to add another. We're going to do our other x-intercept, which is 7 divided by 2, and 0. Okay, so these 3 points should be good enough to get the parabola plotted. Now we can do a parabola. We're going to put this on the vertex, and then it says choose the opening, so it opens up, and then it now says place a point. So if I go to one of the x-intercepts, it lines it up for me. Okay, now the axis of symmetry, that is x equals the coordinate of your vertex, which is 7 divided by 4. The maximum or minimum, we have a minimum value. And the minimum value is the y value of the vertex, so negative 49 divided by 8. And we're going to do the domain and interval notation. So the domain has been all real, negative infinity to positive infinity. And then our vertex is going to be a bracket on the left, so negative 49 divided by 8 to positive infinity. And that should be good.